Hello, I'm Joseph Kasser, and welcome to this podcast where the AI team does a deep dive into some application of systems thinking.
Welcome to the deep dive. We're going deep on systems thinking and systems engineering today.
Ooh, interesting.
It's a topic that might sound, kind of niche,
Yeah,
but I think it's actually way more relevant to our everyday lives than we realize.
I think so too.
And to help us unpack all of this, we're going to be diving into an academic presentation by Professor Joseph Kasser.
Okay.
It was for the International Council on Systems Engineering.
All right.
So even if you're not an engineer by trade, stick with us.
Yeah, absolutely.
Because we're going to be uncovering some surprising myths about systems and hopefully equip you with some practical tools you can actually use in your own life.
That's good.
So to kick things off, I'm really curious about this idea that systems thinking is more than just for, complicated engineering projects.
Well, I think what a lot of people don't realize is that systems thinking is actually a problem-solving approach that you can apply to almost anything.
Okay.
It's not just for designing rockets or bridges, you know?
I see. So it's a way of thinking that can be applied to, any problem, really.
Exactly. Like Professor Kasser, he contrasts conventional thinking with systems thinking.
Okay. And what's the difference there?
So conventional thinking tends to isolate parts of a problem and tries to understand how they behave in isolation, right?
Okay.
But systems thinking, it really emphasizes understanding the whole system and how all those parts interact with each other to create what's called emergent behavior.
Emergent behavior.
Yeah. So think of it like a bicycle.
Okay.
Conventional thinking might focus on just fixing a flat tire.
Right.
But systems thinking considers how that flat tire actually impacts the rider, the journey, and even the environment, you know?
So it's about seeing the bigger picture and understanding how everything's connected.
Exactly, yeah.
But, Professor Kasser also points out that systems thinking isn't always the right tool for every job, right?
Oh, yeah, absolutely.
Like sometimes you do need to just focus on the details.
Totally. If that flat tire is because of a faulty valve, knowing where the rider's going isn't going to help you fix it, right?
Right.
Sometimes you really need to zoom in and analyze the individual parts.
So it's about choosing the right tool for the job, basically.
Exactly. It's about recognizing when to use which approach, which lens, so to speak.
Speaking of lenses, Professor Kasser introduces these holistic thinking perspectives, or HTPs.
He does.
Can you tell me a little bit about how those can help us understand a problem better?
Yeah, so the HTPs are basically different perspectives from which to examine a problem. It's not just one way of looking at things.
Gotcha.
Rather than just list them all out, which there are 9, let's maybe consider a few that are particularly powerful, right?
Okay.
There's the functional perspective,
Good.
where you really focus on the purpose of the system and the processes involved.
Right.
And then there's the structural perspective,
Right.
which examines how all the physical components are organized and interact with each other. And then you've got the human perspective, and that really helps us consider all the people involved in the system, their roles, their needs.
Okay.
And that's really important.
Yeah. So it's like having a toolkit of different mental models you can apply depending on the situation.
Exactly. It's about looking at the problem from multiple angles to get a more complete understanding.
I like that. So you can really choose the right lens for the problem at hand.
Precisely.
So we've got these HTPs that give us a more comprehensive understanding.
Yep.
But Professor Kasser, he also challenges this common idea of open versus closed systems.
He does.
Can you unpack that a little bit for us?
Yeah, it's not really about 2 separate types of systems, but rather 2 ways of looking at the same system.
Okay.
So consider a part engine.
Right.
If we're just focused on the internal combustion process,
Okay.
we might view it as a closed system,
Oh,
right? Because everything's happening within that engine.
makes sense.
But when we consider how that engine interacts with the car, the driver, and the environment as a whole,
Right. Well, now it becomes an open system.
Okay, so it's all about perspective.
It is.
It's not about labeling a system as strictly open or closed,
Right.
but recognizing that the boundaries we set depend on the problem we're trying to solve.
Precisely. Professor Kasser gives this great example of docking in space.
Okay, tell me about that.
So imagine 2 spacecraft that need to link up.
Okay.
If we're just focused on the mechanics of the docking procedure itself, we might view those 2 spacecraft as a closed system,
Okay.
right? Because it's just about those 2 spacecraft connecting.
Right.
But when we consider the mission, which might be transporting cargo to a space station,
Okay.
well, then the system expands to include the journey from Earth, the space environment, and the station itself.
Wow, so the system's boundaries can really shift depending on how we're looking at it.
Absolutely.
And that reminds me of this quote, when we understand that slide, we'll have won the war.
I like that.
It's about understanding how a specific task or problem fits into the larger context. Exactly. And this brings us to the principle of hierarchies, which is a core concept in systems thinking.
All right, so how do hierarchies play into all of this?
Well, understanding how a system fits within larger systems and how its subsystems interact is crucial for effective problem solving.
Okay, I'm following you.
So it's not just about fixing that flat tire on the bike, but understanding how that flat tire impacts the entire bike, the rider's journey, and maybe even the whole transportation system.
Wow, so it's really about zooming out and seeing all the layers of the system.
Exactly. And what's really interesting is that these hierarchical patterns can repeat at different scales, creating what's called fractal hierarchies, but that's a deep dive for another time.
Yeah, we'll save that one for later.
Definitely.
But it sounds like there's a lot to unpack there. Welcome back to our deep dive into systems thinking. We've been uncovering some really interesting stuff about how this approach can help us understand these really complex problems and hopefully make some better decisions.
It is fascinating stuff.
Now, as we kind of dig deeper into systems engineering, Professor Kasser brings up some pretty insightful stuff about the people involved.
Yeah.
And he actually describes 5 distinct types of systems engineers,
He does.
each with their own unique strengths and approaches to problem solving.
Yeah, that's really interesting.
5 types, huh? I'm curious to learn more about these different personalities.
Okay, well, let's start with the innovator. This type excels at seeing the big picture, identifying those core problems, and then generating really creative solutions. They're like the visionaries, they drive progress, they push boundaries.
So they're the ones who are really good at connecting the dots and seeing those possibilities that others might miss.
Exactly. And then you have the problem formulator.
Okay.
These individuals are super skilled at analyzing situations and pinpointing the root causes of issues.
I see.
They may not always be the ones coming up with solutions, but their ability to really define the problem clearly is so essential for finding the right solution.
Gotcha. So it sounds like they lay the groundwork for effective problem solving.
Exactly. And then you have the problem solver type.
Oh.
These are the folks who take those clearly defined problems and apply their expertise to, actually design effective solutions.
Okay.
They're skilled at planning, implementation, and just making sure that the solution actually addresses the root cause, not just the symptoms,
Right. So we've got our visionaries, our analysts, and our architects.
Right.
Sounds like a pretty well-rounded team so far.
It is.
What are the last 2 types?
So next we have the apprentice or the doer.
Okay.
These folks may not be the ones formulating the problems or designing the solutions, but they're the ones who actually make those solutions happen.
Right.
They're the ones who are really skilled at following processes, executing plans, and making sure that the solution is implemented effectively.
It sounds like they're the builders, the makers.
They are.
The ones who take ideas and turn them into reality.
Exactly.
Very cool.
And finally, we have the problem causer.
Oh, the problem causer.
Yeah, now before you jump to conclusion.
I was just thinking, is this a bad thing?
No, not necessarily. This type isn't inherently negative, right? Everyone has a role to play in the system.
Right, of course.
But Professor Kasser's point is that this type thrives on having clear instructions and guidance.
Okay.
They may not be the ones leading the charge, but they're so essential for carrying out specific tasks and contributing to the overall success of a project.
Yeah, it makes sense that a diverse team with all these different types working together would be much more effective.
Absolutely. It's about recognizing that everyone brings their own unique strengths to the table,
And how do you know which type you are? If somebody's listening to this,
Yeah.
how do they figure out which category they fall into?
That's where self-awareness comes in.
Okay.
Professor Kasser really encourages us to reflect on our own skills, our own inclinations, and how we approach problems, For instance, the innovator excels at finding similarities among seemingly different things, whereas the problem formulator is adept at finding differences among things that appear similar.
That's interesting.
So it's about understanding, what your strengths are.
Yeah, I can see how understanding your own type and the types of the people you work with could really lead to better communication, better collaboration.
Oh, for sure. Absolutely.
Maybe even reduce conflict on a team if you really understand where everyone's coming from.
Definitely. And it can help you identify those areas where you might need to, develop new skills or seek support from others on your team.
Yeah, so you know where your strengths lie and where you might need help.
Right.
So we've got these different types of systems engineers all working together. But how do they navigate this complex landscape of systems engineering itself? Like there are so many approaches and models out there.
It's a lot.
It can feel really overwhelming.
That's where frameworks can be really helpful.
Okay.
So Professor Kasser introduces this framework called the Hitchens-Kasser-Massey framework,
Okay.
or HKMF for short.
HKMF. All right, got it. Another framework. There's so much to keep track of.
It sounds complicated, but it's actually quite practical.
Okay, well, break it down for me.
Okay, so imagine a grid.
All right.
The vertical axis of that grid represents different layers of systems, from the product level all the way up to, like, socioeconomic systems, right?
So it helps you visualize how these different levels of systems kind of interact with each other.
Exactly. And the horizontal axis, that represents the different life cycle phases of a system.
Yeah.
From identifying needs to actually disposing of the system at the end of its life.
Okay, I'm starting to see how this could be useful. Like you can pinpoint where a specific problem fits within the broader system and its life cycle.
Precisely. It helps you clarify which approaches and tools are most relevant for that particular situation.
Oh, okay, I see.
So, for example, if you're working on the design phase of a new product,
Right.
you might really focus on tools and methods related to, gathering requirements, building prototypes, and testing.
Makes sense.
But if you're dealing with, the disposal of a large-scale system, you might need to consider things like environmental regulations, societal impacts, resource recovery, all that stuff.
Right, because those are totally different problems.
They are.
So the HKMF is basically like a map that helps us organize information and choose the right path, based on where we are in the system and its life cycle.
Exactly. It's about understanding the context and focusing your energy where it's going to have the most impact.
That makes sense. So we've got these frameworks and tools to help us, but Professor Kasser also makes it clear that they're only part of the equation, right? Ultimately, it's the skill and judgment of the engineers that determine whether a project succeeds or fails.
Oh, absolutely.
He makes this point by telling the story of George.
George?
Yeah, a diligent and hardworking engineer who follows all the processes, documents everything meticulously.
Sounds like a good employee.
Yeah, so what's the problem with George?
Well, George gets so caught up in the how of systems engineering that he completely loses sight of the why. He focuses so much on just meeting the customer's stated requirements. But he doesn't really understand what their underlying needs are.
So he might build a system that checks all the boxes on paper, but doesn't actually solve the customer's real problem.
Exactly.
And then the customer ends up constantly changing the requirements, the project gets bogged down, and everybody's frustrated.
It happens all the time.
I think we've all met a George at some point in our careers.
I think so too.
I know I have. So Professor Kasser is using George's story to highlight the difference between a good systems engineer and an outstanding one.
Yes.
And what is that difference?
Well, the good systems engineer builds the system that the customer asks for, right?
Right.
But the outstanding systems engineer, they build the system that the customer needs.
I see. So it's about going beyond that surface level and really understanding the problem in context.
Exactly. And it's about communication. Outstanding systems engineers are so skilled at asking the right questions, listening carefully to their customers, and really trying to uncover those needs and motivations that are driving their requirements.
So it sounds like it's a mix of technical expertise and empathy and strong communication skills.
Absolutely.
They have to be able to bridge the gap between the technical stuff and the human side of things.
Exactly. Yeah.
So how do we become more like that outstanding George? What strategies can we use in our own work?
Professor Kasser suggests a couple of key strategies.
Okay, I'm listening.
First of all, don't just rely on what the customer tells you they want.
Right.
Right? Don't just rely on those stated requirements.
Right.
Dig deeper. Ask probing questions. Observe their current situation. Try to really understand the context behind their requests.
It's like being a detective almost.
It is. It is.
Yeah.
You're uncovering those hidden clues that reveal the real nature of the problem.
I like that. And what's the second strategy?
Don't be afraid to challenge assumptions. Just because something has always been done a certain way doesn't mean that it's the best way. Right?
True, but that could be hard, especially in organizations that are really resistant to change.
It can be challenging, but it's absolutely essential for innovation and for progress.
And that brings us to, I think, another really important part of systems thinking, the concept of complexity.
Complexity, yeah.
Now, complexity is often seen as, the enemy of effective systems engineering.
It is.
But Professor Kasser kind of challenges that assumption a little bit, right?
He does.
I'm curious to hear what he has to say about that.
Well, he argues that complexity itself isn't inherently a bad thing.
Really?
Yeah, in fact, lots of complex systems function extremely effectively. Think about things like national railway networks, international airlines, those global financial systems we were talking about before.
Right. Those are incredibly complex.
They are.
But somehow they manage to operate with, like, pretty remarkable efficiency, and they're resilient too.
Exactly. Professor Kasser believes that a lot of the time we actually create unnecessary complexity by trying to oversimplify things. We create these like artificial boundaries, we ignore important feedback loops, and we end up with systems that are super fragile and just break down all the time.
It's like we're trying to shove a square peg into a round hole, you know?
Exactly.
Just forcing it to fit where it doesn't belong.
Yeah. And if we can learn to embrace complexity, understand its inherent nature, we can actually leverage it to our advantage.
So it's not about getting rid of complexity altogether,
Right?
but about learning how to understand it and manage it effectively.
Precisely.
That's a really different way of looking at it.
And that brings us to a really, really crucial question.
Oh, what's that?
If complexity isn't the enemy, then what is?
That's a really good question, and one that I think we'll need to explore in the final part of our deep dive.
Yeah, let's do it.
Welcome back to the deep dive. We've been really digging into systems thinking and how it can help us navigate the complexities of, well, pretty much everything.
It's a powerful way of looking at the world.
It is. And before we wrap things up, we left off with a pretty big question hanging in the air.
Right. If complexity isn't the real enemy of effective systems engineering, what is?
It's something I've been thinking about a lot throughout this whole deep dive, you know.
It's a question that deserves some careful consideration.
So what are your thoughts on this? Where do we even begin to untangle this?
Well, I think if we look back at everything Professor Kasser talked about, there's this recurring theme.
Okay.
And it's the importance of understanding.
Understand.
Yeah, understanding not just the systems themselves,
Right.
but also the problems we're trying to solve,
Okay.
the needs of our customers, and even ourselves as systems engineers.
I see. So it's not just about the technical stuff.
It's not.
It's about understanding the human element too.
Absolutely. And if we connect that back to this idea of complexity,
Yeah.
I think a big part of the problem is our lack of understanding.
So you're saying that maybe the real enemy isn't complexity itself, but our tendency to try and oversimplify things.
That's a big part of it, yeah.
Because when we oversimplify, we miss all those crucial details.
We do.
We create these artificial boundaries.
Right.
And we end up with systems that are fragile and prone to breaking down.
And ironically, by trying to oversimplify things, we often end up creating even more complexity in the long run.
It's like that saying, for every complex problem, there's an answer that is clear, simple, and wrong.
So true. Systems thinking really encourages us to embrace the messiness of things.
The ambiguity, the interconnectedness of it all.
Exactly. Instead of always searching for those simple solutions,
Right.
we need to really cultivate a deeper understanding of the systems we're dealing with.
And recognize that we're not dealing with these static, predictable machines, but these dynamic, evolving systems that are constantly interacting with their environment.
It's a different way of thinking about things.
It is. And this reminds me of what Professor Kasser said about systems engineering standards.
Oh, right.
And how so many of them focus on the wrong aspects of the system lifecycle.
Yes. They place too much emphasis on trying to control and predict everything.
And that ends up limiting their effectiveness.
It does, because by focusing too much on documentation and processes, we can actually stifle the very adaptability and emergence that makes systems so effective.
So it's not about controlling systems.
Right.
It's about understanding them
Yeah.
and adapting to their inherent complexity.
Exactly. And that requires a real shift in mindset.
A willingness to let go of that need to control every little detail.
Yeah, and embrace the fact that complex systems are always changing, always evolving.
It all comes back to what we were talking about before,
Yeah.
asking uncomfortable questions and embracing that discomfort.
It does. We need to encourage systems engineers to challenge those assumptions. Question the status quo and get comfortable with not having all the answers right away.
Because that's where the real innovation happens, right?
It is. That's where those breakthroughs come from.
It sounds like a call for greater humility when we're dealing with these complex systems,
I think that's a great way to put it.
recognizing that we don't know everything.
And being open to new perspectives and approaches.
So the biggest barrier to effective systems engineering, might actually be ourselves.
Hmm.
Our own resistance to letting go of that need for control.
Maybe, yeah.
Embracing that complexity and acknowledging that there's always more to learn.
It's a thought-provoking idea.
It is. It's not about eliminating complexity altogether,
No.
but about learning how to dance with it.
Well said.
This deep dive has been a real eye-opener for me.
You too.
I feel like I have a whole new perspective on systems thinking.
It's changed the way I think about things.
Not just in terms of engineering, but problem solving in general.
Absolutely.
And like you said earlier, like any good deep dive,
Yeah.
it's left me with more questions than answers.
And a desire to keep exploring.
Exactly. So, to our listeners out there, we'll leave you with this final thought.
Okay.
Could it be that the key to navigating the complexities of our world lies not in seeking those simplistic solutions, but in cultivating a deeper understanding of all these interconnected systems that surround us?
That's something worth pondering.
It is. So keep asking those uncomfortable questions.
Yeah.
Embrace the messiness.
Don't be afraid to get your hands dirty.
And remember, there's always more to discover.
There is.
Thanks for joining us on this deep dive into systems thinking.
It's been a pleasure.
Until next time.
I hope you enjoyed today's deep dive. If you'd like to discuss any of the questions or anything that you heard in the podcast, or would like the team to do a deep dive into a different topic, please join the LinkedIn group and let me know. I look forward to providing you with many more deep dives into the applications of systems thinking. Take care.